Hey guys, Colleen here, and today I'm going to be working on this Fender Pro Jr. amp. This is a modern amp, and as you guys know, I do service a lot of vintage amps. However, these, plus like the Blues Juniors, hot rod amps, Fender reissues, stuff like that, I do service. I find that these can certainly be workhorse amps with proper servicing. These are good candidates for mods too. I've installed quite a few of the Frommel mod kits for people, specifically for like these and the Blues Juniors. Without further ado, let's go. So we have a single input with volume and tone controls. It's common for people to upgrade the speaker, and in this case we have an Eminence Legend 1058 installed, which sounds totally bitchin', and we've got a pair of EL84 output tubes and two 12AX7s. This amp came in with a blown fuse. In this amp, the fuse is clipped onto the circuit board, so I'll remove it to show you guys. Visually, we can see that it's blown, but here's how you test it just in case. I'm switching my meter to the continuity checker, and it'll beep when there's a connection between 2 points. When I put a probe to each end of the fuse, you can see there is no continuity, so the fuse is not going to pass any juice. Got the new fuse in. This is my Variac/current meter. It's showing the line voltage right now, which I'm going to turn all the way down. And I'm switching it to show the current draw. This way I can slowly turn up the line voltage while making sure that there's no major current spikes, because that would mean that something in the amp is shorted. Current draw looks normal, so let's evaluate the amp and see what might have blown the fuse. Okay, well I can see that this tube is turning white near the top, which means that the tube has lost its vacuum. The tube failure is likely what blew the fuse. Let's go over the work I'm going to do. So of course we're going to replace the output tubes, and then we're also going to upgrade the filter caps. I typically recommend replacing these with F&Ts because these stock IC caps don't have the longest lifespan. We're also going to cool the output tube bias by replacing a resistor. This is common for the Pro Juniors and Blues Juniors because the tubes tend to run pretty hot in these amps. So yeah, I like to cool down the bias a bit for reliability and to promote tube health. And then of course we'll clean the controls, sockets, resolder the PCBs, tighten up the tube sockets, and that's pretty much it. Before I remove the board, I will remove the LED from its housing, and then I'll unclip the output transformer primaries so that we can flip the board all the way over. With the PCBs, I like to cut the components out and then remove the leg from the other side of the board. And that's to prevent the trace from lifting. With these PCBs, I like to use solder wick instead of my solder sucker because it's a little bit lower of an impact to the traces. Basically, it's important to watch your heat when you're soldering on the PCBs. While the board's out, I pretty much resolder every point on the board. The solder, especially on like the larger components, is pretty prone to cracking, so preemptively I just like to give the whole thing a resolder. This resistor here, R29, is a bias resistor. It's currently 15,000 ohms, but we want to increase it a little bit to restrict a little more current flow through the tubes. I'm going to use an 18K resistor. Later on, I'll show you how to check the bias on these amps. So lastly, I'm going to resolder the tube PCB and then clean and tighten the tube sockets. To find out what bias range we're looking for, we need to measure the plate voltage first. We've got about 319 volts. Tubesandmore.com has a handy bias calculator that I like to use. It's under the tech articles section on their website. You just enter the plate voltage and the tube type, and then it'll show you a range of bias points. I typically look for around 70%. Now that we know we want roughly 26 milliamps per tube, let's see what these tubes are measuring. First, I'm going to measure the resistance from the center tap of the output transformer to the plate of each tube. So we've got 96.7 ohms on one side and then 96.4 ohms on the other. Now I'm turning my meter to DC volts, and I'm going to measure the voltage drop between the center tap of the output transformer and the plate of each tube. We've got 2.42 volts on the first side and 2.61 volts on the other. Here's where Ohm's law comes into play. I'm going to divide the voltage by the resistance to get the current reading. And that comes to 25 milliamps of bias current on one side and 27 milliamps on the other. I would also like to thank DistroKid for sponsoring my channel. As we all know, DistroKid helps musicians upload their music to all major streaming platforms. Viewers of my channel get 30% off at the link I will post below, so go check it out. All right, guys, thanks for watching. I'll see you next time.